So there we go. And we're live. Let's go. So second stream for today. In the last stream we designed all of that. The bottom part of the bottom part of our robotic arm. I think I will now continue over to the top plate where the do I have drawn here to this top plate right here where the first arm is located at, and also let me just see if the stream is also showing on Discord. Maybe check also on YouTube because it's not showing on Discord. Okay, yeah, no real life here on my end. Okay, that's good. So we now will continue with the top plate. There was one thing I wanted to add to the bottom here, which was a stand so that we can just put some weights on the sides here of the Arduino, of the robotic arm. It's this one right here. Just you see the Arduino in the middle, the bottom part, this one right here, and then on the sides I want some kind of like foots to stabilize the robotic arm so it won't tip over if we lift anything or if we lift some light or heavy weights. So we will then continue on to the plate above. Oh no, first of all we need to drill some holes into this right here. We can just sketch let me just go into the part again. There we can disable the base plate for now. We now just want to focus on this part. Just select this top right here. Then in the tools we can make a create sketch. Just take the recommended one. And now we want to just make some holes to the sides here. Some holes right here. And then we see that there is a problem because we want the sketch in the stepper mount low. Okay, it won't allow us to do it in the mount. Just delete this right here. We can here create a create sketch. I hate this console thing down there. Can't really see anything. And it's just... So we have our sketch now. Wait, this doesn't make sense. The navigation here of this I'm not the biggest fan of, but I think we'll have to deal with that for now. So delete, then don't delete anything, perfect. Why aren't you doing anything? Toggle visibility, we want to delete that... Why can't I delete this? Now we can. And delete. So now what we want to do is we want to create a sketch from this end. Part design. We go into create sketch. On the X plane. Then we want to create some of here. And some right here. So that we can go ahead and close this tab for now. We want to select this face and make the mirror sketch 05 it is. It's current. That's not the current face. And then this sketch 5, we want to have it up there. And I see what the problem is. Perfect. So if we go into the part right here, we have in our y-axis move the transform, and we want to move it down to the normal position again. Just like that. And then we should be fine if we go back into our part right here, toggle the visibility to false, and then in part design have a look from the top, and then we see this here already that we can delete that face, and then here on this we should be able to now create a sketch, and this sketch now will be correctly oriented to this. So what we're gonna do now is put some holes along the sides here so we can mount our robotic arm. Put some on here and another one down here. We will adjust them in a second, but first of all we need to figure out how we cover up the screws. I will show you what I mean in a second. I'm thinking we're using those here. This length, it is not 20 millimeters long. It should be 20 millimeters the head, or the 20 millimeters just the screw, and the head is another 3.5 millimeters long. So we will just go ahead and make the first holes. Oh wait, no, that won't even work. Oh yeah, so the stepper motor on this will be... Where did I put the stepper motor now? Damn, my table just got really messy. The stepper motor, I'll just show you here. So we have the motor, we have for example this top plate, and I think we should have enough space to put some screws in there, but I would like to avoid having anything down here so that I can just screw everything on top. So I will have to scale up our pad right here, so I will make that one to 5 millimeters, like that. And now what we can do, we go into the radius, set this radius to the radius of the screw. Just get all the stuff together. Stream. Then we will just have to measure what the diameter of the screw is, and I would say it is 5.2 millimeters, 0.1. It's usually the error margin my 3D printer makes. Let's make it a bit. Let's make it 0.2 just to be safe. Do not need to reprint everything. So we will just copy right. We will just copy that for the rest. 5.2. 5.2, and I just noticed that this won't work because the sides are not big enough. We will figure that out in a second. It's at least what we need right now. 5.2. Now what we could do is going in the original sketch right here and then adjusting this to maybe like 30. Then we will have a bit more room to work with. So now if we go into this sketch, we will be able to see, and you will be able to see too, there's much more room in here. So we now can just go ahead and take the vertical line down to the center point and just put it onto, let's try 70. 70, which is perfect from the center. Yeah, you divide the 140 should be the center. No, 140 is the center circle, if you would define it like that. This side should be fine, this side should also be easy. 70 already almost perfect, and then here also 70, and I just broke it because I selected the, yeah, chill out, man. Nope, this won't work. Here from this to this, and also 70. So now we have the constraint there, we have the constraint there, and this constraint. Okay, perfect. This constraint, yep, everything works for this setup. Now we have to drill the holes, but this thing is, we're not drilling them all the way through, but we're drilling them only so we can cover the head inside of the wood, so that they don't stick out 3 millimeters and would be scratching on the plate down here, which would break it at some point. But we want to cover them up, not like this, but down here, so they won't be visible anymore. So now what we're doing is just going ahead and closing the sketch. Then we will just make this visible, select our sketch right there and invert it. Not 5, we want to invert it 3.1 millimeter. It should be the size of the head. And now we will select this face right there, select another hole, then we will just quickly go, no, it was the right thing to do. Going in here, we will again, as we saw in the previous stream, can just select or get like kind of a copy of the hole, so we can just get the center in there. So now we will still have to draw our circles in there. I like to do them a bit bigger. It's just easier to adjust them in a second with the... Nope, I want to hit the center there, like that and that. Now if you press R and scale this down to the screw is 3 millimeters in diameter, like here. Like this part was 5 millimeters. This part was 5 millimeters, the head, and this part is 3 millimeters. So perfect length for my printer, and still not being too big to not being able to work with them. So 2.9 millimeters what we are giving it, because it should have a little wiggle room in there. That's why we're giving it 3, because the error margin is also another millimeter on there. So just go ahead and scale this one up also to 3. Should be of good length for that. 3 and also 3 millimeter. So there we go. Now this we can just go ahead and go through, and also, yeah, there we can just do another 3 millimeters to not go through everything we have, or not through the other parts. I'm not sure if it will actually do that, but sometimes it does. So now we will just have, wait, we will just see that this looks quite good. Now we will change into the part again to make the base mount visible. Then we will make this one. I know we actually won't make it invisible right now, but we try to move it to another side like that. Nope, we're not actually doing that. We're just going into the stepper mode again, pressing transform and scaling it up a bit more, and we'll keep that for now. We go back into the part design. In the part design we create we select our upper ring like that. Oh, come on. So now, for whatever reason, it is displayed up there, which we do not want. We will get again to the part studio. There we will be not selecting this part. We go into the part studio again. Then in this part, just select it. We will edit the sketch real quick to this inner circle not being 140 but 130. We'll probably put another 1.5 hours to the printing time, but we'll take that for now. maybe I'll get like a thought later on, and then I'll maybe change it. And yeah, so we just take a look at the top again. Take this up here, make a sketch. It is in the perfect height for that. We take the circle tool, make the circles here, well, pretty easily. So just going on there. Rotation tool will be 3 millimeters, 3 millimeters, 3 millimeters, and 3 millimeters again. So what we're having now is those circles. Again, scale them up with 70 millimeters to the sides. This will also be 70 to the side. The top one was L, right? No, I. And 70 centimeters to there, and another 70 centimeters down. 70 millimeters, sorry. We are not creating a big, well, this big robotic arm right now. Or just for now, maybe in the future. If you guys like the robotic arm I'm building now. So we have our constraints all set. We want to remove it now. From the last one I already have now. We probably take those 2 centimeter screws. I've taken 3 millimeters off them, so we will just need to 15 millimeters downward. No, I don't think we will take the big ones. Then we're taking the 60 millimeters, then we have 30 millimeters left, and that is fine to me. Drill holes 30 millimeters down. Also, a pro tip for 3D printing is that if you're building a large structure like this, just put some holes inside it, if you want to strengthen it. So normally this would be completely hollow and you can just punch through it really easily, but if you put more holes in it, you will have it will be in the, how do you call it, the slicer program. It will make some extra movements around it, which means that there will be more structure in it, so which means strengthening it. Yep, so just a little tip there. I will probably implement this later on here as well, especially if I look at this right here. I could just be a bit more rough on it and just break it with just a little push. So we have to see that we are making there some good structures in here. They're not easily breakable by just the stepper motor or the robotic arm falling to one side, which wouldn't be the best thing. So we're now just going to continue on to yeah, the holes should be finished. Let me just see it, if everything is done that I had planned so far. Here to the view again. Sketch 7. Yeah, I just quickly wanted to remove that because I accidentally created the sketch on the wrong socket. But I think there, oh yeah, I also accidentally removed the cutouts, so they were 3 millimeters like that. There we go. Damn, this console down here, it's just so how is it called? It's the view report view. Don't need that, just pissing me off. So put all the stuff back here so I won't mess my room up too much. Everything back into the tables. Now we will have to go on with, let me just close a few tabs right here. Don't save. No. I will quickly have to check something if my video editor wrote me something. Nope, he hasn't. Yeah. Now we're going to move over to the top part. We will just create a new body for that. This body we're calling it how can I rename it? I want to go into the part design. Part design, like that. Rename down here. I could have also just pressed F2, but yeah. So this will be the base plate. You will see what I mean by that in a second. And in a second I mean that I want to quickly move this run. I will start by this, moving it down way further. Then we will continue with the transform, which will be also moved down a bit further. Kind of like this, assembled. And now we will go ahead and create our sketch on here. Base plate on the X and Y axis. Now we just gonna go ahead and make the outer circle, which will be a centimeter bigger than the one we have inside, which is 160. And then I really think that it's not directly centimeter, it's not looking, you know, it's fine, this size is fine. So we will go ahead and make another inner circle, which we actually do not need right now. I just noticed. No, we need the outer circle. We will make it 160 big. Then we will go ahead and add a little rectangle in the center. This rectangle will be, let me see, the size of this little fixation part of the stepper motor. The stepper motor video will hopefully be uploaded tomorrow, and then you can, if you don't know how the stepper motors work or what they even do, you can learn about this in this video then. This will be the first video that my new video editor edited, so will be of much better quality than the last ones, which I edited. So let's just take a look, zero out our pilgrims right here. This will be 3 centimeters, no, 2.9 centimeters in this direction, and in this direction it will be 5 millimeters. Wait, what was the size of this right here? This was 7, okay, then there was a problem back then. But the width of this should be 2.95. I think I will adjust this as well, because the fit was quite good on them, that one. So just going in here. Now if the fit would be, the x-axis would actually be a really tight squeeze. Let me just quickly see in the stream. I don't think we have any viewers right now, which is a bit sad. But I mean, I get it, it's a Sunday afternoon. People have to get ready for school and work tomorrow, so yeah. We give it the same as last time. 9.5 or 0.9 I think will be good. Which is not good because the error margin needs to be also calculated with probably 3. So this should be a good hole right there. If we take a look at the sketch, it should be approximately be that size and also fit in that quite well. Damn, that's actually a good way to analyze this, because it fits perfectly, at least with my eye. Would be cool if that would be the outcome of my print then. So then we will just continue on. I will print this hole completely through. Like that. We will just extrude this face now with this tiny slit in the middle. This will be scaled up to 3 millimeters. Oh no, wait, I can't just choose my thing there. We'll have to measure it. I just put away my little measurement unit right here. This one right here, it's like a digital ruler for measuring distances. You can just quite accurately just go ahead and just now see the size right here with one of these 7 segment displays, which will probably be uploaded next week. So we need the height of this, and we can just simply measure that by knowing that it is 6 millimeters, or half knowing 6 millimeters, which is quite good. 6 millimeters. And then the thing is, at the base plate I want to add another special circuit, which then will be 100 and don't make me any stupid mistakes now, please. 52 I would say would be quite good and still enough to stand out from everything. So I would have to do that again because it wasn't centered directly. So the circle tool, which has no shortcut, just completely centered. R for the rotation tool, 152 to the outer diameter, and then from that we will connect the... Oh man, I just realized that this probably won't work as simple as I thought. So we have to do another circle, which will be right there and will be the same size as the one above, which was 160. And now if we exit out of the body, we can just scale this one down. And that's where my explanation from last stream comes from. Going here. And I'm not sure how far we should go down. 1 centimeter should be good. Should be alright. But I'm not 100% sure. It is... This one was 5 millimeters tall. This one was 2.5. If we put them on, it will slightly cover up this hole right there. 10 should be fine. And if not, well then it's not fine. So next we have the next thing, which will be the motor mount, which will be this construction right here. The other half broke out from my last print, and this time I want to have it centered. We have the hole there now, but this shouldn't be a big problem. We're just gonna go around it. This time I will leave my ruler open. Starting to speak German again. So let's just go ahead and see on the circuit we had an idea with the mounting board. Let me just show you this real quick. The idea was that the motor mount will be, for example, this right here. And then this right there. The screws will be, or the motor will be mounted on here, on this scale, kind of like that. Bit further behind probably, but it's quite fine for what I wanted to show. So then there will be the nuts will be in there, and the screws will come in here. They will also stick out here a bit. And so we have like contrast just at this. And then the thing, we have our stepper motor showing. Wait, let me just, sorry, I forgot to make it a bit bigger. We have our motor mount right there from the side. This little abomination right there. And what we want to do is now design this part. I mean, I'm not too sure about the sizes. But they should be okay. Should be alright. We will figure this out on the way. Wait, let me just make it a bit more easy to understand what I'm doing right there. Just by those screws, and then there will be 2 screws that will be able to go through there. And on that front then we will have to mount the robotic arm, which will, or the first side of it. It will go up like there. That's not the stop. And then we will have to I will now give it a bit more space than it will be in the end to visualize it better. Then will be screwed in there and everything, and then might even go as far as down here. We'll see about that, how deep we're gonna go. And then this will be the start of the mechanism for controlling this one right here. I think this actually turned out quite good. So let's just start by creating a... let's just go into the base plate. Click on transform and make it a bit further down. Like that. Now if we go ahead, wait, I'd want to try it if I go like a bit further. It's going to happen then. It will just be slide really clean on top of this. This other plate, and we'll have like a closed part right there. We also can't forget about the cable management, but I'm sure for the first prototype or before I'll print everything, I will have to wire up the electronics anyways, so we can see if even the stepper motors work. I haven't assembled, I mean I tested them once, but it was quite tricky to power them, and it was just one, and I want to power all 3 of them that we'll need, and then we'll see if if it's even possible to build this robotic arm, or if my skills won't. If I don't have the skills, I will learn it, but yeah, if this even works with those motors, or if I have to build like an external motor driver for them, because they won't get enough power maybe through the Arduino. But the Arduino R4 should be able to now get up to 25 volts of power supply, which means that we are able to build a lot more. Wait, let me just stick that in. That's why did they make it like that? There's like a hole in here. There as well. Anyways, they up to 25 volts, and I think 5 amps, which means there will be a lot more opportunity. So we'll just continue. by creating the next, first going into part design again, and then creating the next body. We also have to rename this file and save it as robotic arm, like that. And then I also wanted to open the folder of the robot arm to quickly, let me see where videos, projects, robotic arm v2, and under there I had already the base mount, which will open the second tab right here. Wait, let me see something, how the assembly even works on the, because I'm not sure if that's even, how do you go about the assembly now? If we see and reverse engineering, no, let's just take a look at another good YouTube tutorial. FreeCAD assembly. Damn, this guy again. Now I have to subscribe to him.
Hello everyone, welcome back with a FreeCAD basic tutorial. Today I will show you how to assembly parts. For example, I will create two parts. You can click create new, change into part design, and create body, create sketch, choose top plane. In here I will create circle, and we can set for radius into 10. Press enter. Next, use pet tools to convert into 3D model. In here I will set into 40 project.
Wait.
Here in save this object, click files and save. I will give name in here into part 1. Save. We create again new parts. Click create body.
Oh no! God damn it! I think
rectangle with circle in here. And can set.
Wait, let me see if I can. Can I drag them down in here? Oh, thank God. Okay, then I will order them in a good direction now. So if we press on this, we will call this base plate. Then we will take the base plate here, which will be the transform and placement, which is good. Base plate. Then we will make another one and call this the Arduino base Arduino mount. Then we will drag the Arduino on there, save it. Next up we want to make the base stepper motor mount. There we go. Wrong button.
Critical radius into part into direct object. The name into. Now you can create new document. You can click here, create new, select this files, and I will change labels into assembly. Label names for these parts. The next, to assembly the objects, you can go or change into A2 plus. You can install this feature, like you can go to tools and click add-ons manager, click A2 plus add-on.
Oh, so it's not pre-installed. Okay, that's draft TNT path. Okay, tools, add-ons manager. Okay, don't care. A2 plus.
And you can click it.
A2 plus, come on. Load. It's just. "3D printing tools." Yeah, no, I have to take a look at many of them. Because like 3D printing tool, now I have to export it, then in Cura, Ultimate Cura, I have to import it there. Then slice it for my 3D printer. But I don't want to do this all the time. So and I can export it as an OBJ, I think, or in specific form, and I will take a look at that if I can do that. Or in so I am just going to go and install the A plus library now. Okay, it's just directly installed. Oh no, it's not. Now it is. Successfully installed. That's awesome. Restart later. Let me just see if everything. Wait, maybe it is. So everything is working. Robotic arm, and we're just gonna make it a closed document, save, and there we will now create, as he said, an object called assembly, and now I don't think we have the add-on right now, so let me just save everything, open it again.
Install here. After you install, you can close and you can restart again.
Time we can
here we can close.
take a look at the video again.
Next, you can click this icon to add parts, but first we need to save this assembly document. Okay, I will set the name into assembly.
Assembly. There we will make it into the A2 plus. Then we will add a part. Let me just get out my file directory in here. I can't, oh man. Okay, I can't paste my file directory, so we have to just videos, projects, hovercraft, no, not hovercraft, whoops. Where is it? Robotic arm version 2, and then all of those, motor, assembly, base plate. Can I somehow fix this? No, okay. So at this part. Oh, okay, I have it just here. Then another part. Base mount, okay, base plate. like that, and between that we also have the stepper motor mount, which is this right here. Now let's see how we assembled all of that.
Click save. The next we can click here to add parts. I will click in part 1, so it will be automatically attached into assembly command. Click again in here, and we can set into part 2. I will set again part 2. So in here we have part 2 objects in a drawings. Now to assembly, you can active for this feature. So you can active for constraint dialog box. You can click. Will be show constraint tools in here.
Okay, let me just drag this to the side.
Active for this feature. So you can active for constraint dialog.
Okay, so
box. You can click. Will be show constraint tools in here. Now I will move this face into in here. You can select at this point, and also in here press Ctrl button to select multiple face and click at this point, so the object will be automatically.
So I apparently can just take this point and this one. How did he?
Now I will move this face into in here. You can select at this point, and also in here press Ctrl button to
this part and this part. How do you select two parts in here? Control. Okay, it's control. Perfect. So I want to have this part and this part top of each other. Maybe not like that. Like that, and that part. That and that part. Why isn't this working? And on top of here, this looks a bit closer to it, but not. I mean, it's kind of doing what I want, but also it is not.
It will be also in here. You can click these tools to make correct constraint between these two faces. You can click it, so it will become a parallel in this face. Okay, very easy to assembly part in FreeCAD. You also first you can click part 1 transforms, and in here we can rotate. I will rotate in 2 axis to here. Click OK. Next we select again at this face, also in here. Sorry, but first we need to accept and select this face with these tools, and then we can select with these two faces.
Okay, mate. Try this tutorial here.
Back to another 5mm hole in here, so we're going to need a 5mm fastener as well. So we've got something to work with. Now, going back to what we said about assembly, this extrude, or your finish. Now we've added that. Well,
why does US assembly Is there a tool called assembly in here? Let's also install that. Can't hurt to have more.
So how do we align it with this hole? This is where another coordinate system comes in, and it's called the hole axis. To add that, let's come back to the clip, because we've got to add it to this clip, and we're going to add that to one of these holes. So I'm going to take this hole here, select the top of it, because this is where the bolt will go through, and I'm in the assembly 4, and we can use our create a new coordinate system, or we can come up to the assembly and create a datum object, and we see the new hole axis there. Click that.
Okay, so does it also restart now? Why not? So I'm not sure for how long I will stream now. Maybe for another hour, and then we'll take a look how far I can get here. I will go ahead and make an assembly 2. Assembly 2. And there I will try the assembly 4, which might be more intuitive.
Assembly. This one here. So, and come back to the assembly 4 workbench. Let's add a fastener. So using the
So we also open the others in here. So we have on one side the base plate, which was a dumb idea to open it in a second one. We have the base plate. Yeah, so the problem now is we would have to model the 3D, wait, I have an idea. The base plate, and we now need the stepper motor mount. Stepper motor mount is right here. Stepper motor mount and the base Arduino mount, like that. Now we can just take the base mount, select this right here, wait, what did he do again to
fasteners drop down here workbench. This one, fastener. So using the fasteners drop down here, or assembly fasteners, we can insert a screw, a nut, a washer. The screw will be also a bolt as well. We can use bolts in there.
right in the assembly. Whole axis. Then we can do the same thing for the base plate. We will make it an whole axis.
Fine. Hit screw will be also a bolt as well. We can use bolts in there.
Okay.
So I'm going to hit insert screw, and we'll get a screw that's inside. You can see that there. Let's come over to the model tab. And you can see it's an M6 times 8 screw that's been added. And if we click on that, we've got all of the view properties. On the data tab, we've got the diameter here. The assembly, I'll click.
How do you get these
It will get
screws?
reflected back, and we'll name. Now the important thing here is that we're using a body workbench add-on. So this has added this icon. So this local coordinate system will connect to our first part. Everything else that we add to this, why I disable this axis cross, because we can't really see it. Let's do that. Toggle axis cross to turn that off. So this local coordinate system will connect to our first part. Everything else that we add to the scene will be connected to that part which we've just added. If we also look on the assembly floor, we'll see this icon here, which is the fasteners workbench add-on. So this has added this icon here. So this local coordinate system will connect to our first.
Do I have the screw icon really? I don't think so.
First part. Everything else that we add to the scene will be connected to that part which we've just added. If we also look on the assembly floor, we'll see this icon here, which is the fasteners.
I don't have that. I guess it's sitting under there or somewhere. Oh, right there. Let's just watch the video.
So we've got something to work with. Now going back to what we said about assembly, this extrude, or your finished fusion or finished boolean, needs to be in a standard part. To place that in a standard part, if we look along the toolbar, it may be in a different position for you. You'll see this create part. Creates a new part, makes it active.
Yeah guys, I think there's not too much reason to it if I just watch the video right here and you guys are just watching me watching the video and saying nothing. So I think I will end the stream right here and learn a bit more about the assembly part. Or I could just move on with this shit I want to do, which was not the assembly, but the motor mount design, which probably would be even more productive. Yeah, fuck this. I'm moving on to the base design F. Can't quit it now. So the basic idea will be based on let me just drag that in. Well, basic idea will be this mount right here. I think we can now just go ahead and modify on top of it, because it looks quite good. You see it right there. We can just improve on that, which means we go ahead and extrude that a bit more. The pad, instead of making it 2, we at least are going to make it 5. That then means that we will have to create where's up top is right here. There we go. Top is like that. And then we want to go down to the bottom, and on there we want to go into the part design and create a sketch beneath it from the bottom. And then the thing we're going to do first is assemble this, or paste over those holes. And then instead of pasting over the holes directly, we are going to take those screws right there, which I never used before, and I don't really have an idea what I should do with them or how I do with them. So let me see if there's any information on top of the screw system. So there are M3 screws. They will go through here. How do we go about that? Can I scale this, or can I change anything here? If I tell it like, okay, then it's just gonna change a bit in that direction, but I think that should be fine. So now if we take out one of the screw things, and we are just going to, yeah, that's the same shape for those. The hole is already in there. I mean, the hole should be the right size. Wait, why is it for, wait, was this designed for the larger ones? No, it wasn't, right? Oh man, let me just see if I can untighten them. So just point the camera down here a bit so you can kind of see what's happening. I'm just trying to unscrew these bolts. So also this one right here. I don't have the correct tools for it, so I'm just gonna use this little, how do you call it? Is it still a scissor, or it's like the thing where you can cut off wires with and just, I don't know how you call it. Anyways, so we have our micro ruler right here. Let's just trim it, and then we're going to 4, 5 it's staying. At 3.5. No, that's not, shouldn't be true. Let me just take a look at the sketch right here. 3.9, shouldn't it be like 2.9? Let's just make this to 3. But how was the quality of going through that? You know, there is no resistance but for it. So then let me just see if we unscrew all of them. And go ahead. Yep, unscrewed them all. You can now take this one better apart. Oh, we can take it apart now. So the thing is, you slide it over like that. I'm not sure if I will be able to get it over it again. Yep, works quite fine. So if I take a look at the size of this, should be the same on both sides. (41.3 millimeters), and this is 41.5. That's way better. So just turn it off again, and now we're just gonna know that those holes need to change a bit. 3 and 3 millimeters right there. So now if you're going back into here, the sketch, and pulling out the ruler, you're going to see it's changed. The thing now is, we want our bolts right here. It will be inserted like that. I don't know how you measure them, how to... Let me see if there's a video here. FreeCAD. Nuts. Nut holes. There we go. Please don't copyright strike me. Yeah, okay. Wait a second. Do I have this library? Probably not. I do not. I will take a look though. Why can't I manage them? Just give me that and I'm happy. Fastener successfully installed. Restart it now. I mean, I don't have too much open. Shouldn't be too bad. Work mount. So if we go into the fasteners. Whoa, yeah. There are a few of them. We will take a look at the sketch here again. And we can just go ahead and delete everything. So we can just go and say fasteners and watch the video to the end from this guy. I that's okay. So that's how we're gonna do it. We are going to create a wait, come on. Din ISO 4000 something. I fucking hate that shit. Here. Machine screw nut, that's all I need. Just here. So let's see if that is the right size. We know where to go and oh no. So it's not that. Okay, no, it's kind of annoying me here. I don't want to create anything new here. I will take a look at that later, but what I'm going to do now is creating an extra object, new one, which is the golden nut. Then I will go ahead and create a new sketch for this nut. Then there will be placed this. It's an hexagon, right? Yeah, it's an hexagon. That's hexagon. So we will have to check now the size of the nut itself, which I'm saying it's 4 millimeters, but in reality it is 5. Yeah, it's actually 5. Damn. 5.2. It's 5 point. What was it? Oh, it's even more than that. It is. Let's zero it, and then we are going to be taking a look. 5.4. So like that, and then this is going to be oh, perfectly fell into the right one, but not now. This will be 2.3 millimeters deep, so 2.3. Now what we're doing is transform here this. Oh, come on, man, that's here in the nut. The placement is 2.9, no, 2.8. 2.8 seems fine. And now we are just going to overlay it into those others right here. And the bottom so I just need to add a slight hole or something to see where I'm actually going with that. I don't know if there's something like a transparency or something, which would be kind of cool. Because just seeing it like that is let's just close this hole again, put it all the way through. Now if we're back in the nut right there, we're going to place it a bit deeper, and then we will have the just going to put it in here, making it a bit more centered, like this. And then we have Can I copy? Okay, then I guess not. But at least now I know how to make this nut. Which means I don't actually need to know how to create all of those things. Oh man, just brain fog here. We will create the sketch on the object, cancel. We will select this back right here, create a sketch on this. It will be on the body. Let's go ahead and go back into the sketch. So delete this. Now in here we have the 1, 2 and the 3. If we now just go ahead and pull out our hexagon right there, we have this from here to here, which will better if we use this one. So then we have this at 5 point, what was it? .4. Same goes for the other holes. Let's just from here to here it will be 5.4 actually, quite well made. 5.4. Like that, and that is theoretically all we need. The only thing to do now is to send it, but before that I want to rotate it. Can I somehow go ahead and let me just search it up. Let's go ahead and search for FreeCAD rotating sketch. I don't think there is a nope, there is nothing. which means I will go ahead and leave it like that, or not leave it, but then I will now go ahead and say extrude, and they say 3.4. Then I will check how far it is actually, and then I will see that it is actually only 2.3 away. Like that. That looks way cleaner than before. And then I will send this one to my 3D printer. I will go on to export. Here, export. Motor mount again. Wait, I can select another. Smash. Let's just open up Ultimate Cura to slice our print now. Then I will quickly go ahead and print all of that, and we can see how well it fits and what to do. So the print is can go in here, but let's just clear the folder. Cura always takes time to load. Here we'll go ahead. Then, and our next step in that creation would be to actually make it so we can mount something to it. By that I mean I'm not too sure myself how to go about this. Let's see, do I have still have Blender installed? Yeah, I have Blender installed. I would like to just do a quick prototype in there and send the... Please don't tell me it's... Yeah, I haven't played games for so long. Don't need Steam actually. Why is Doom open? Steam, hello. Can you update Blender faster? So then we will go into our print, motor mounted OBJ. We will have to rotate it because then if we don't do it, it will would fill in our tiny gears right here. So we just gonna go on slice, 0.2 millimeters margin, 40 minutes, save. And I'll see you in a second when I have the 3D printer going. And there we go, the printer is going. And let me just check if I could have reduced the time by a lot. Ah, it's fine. Then we have a solid piece. So if we now open Blender or try to open Blender again because it gave me an error message, we can there we have Blender. We are just quickly cleaning up my desk so I have some place to 3D model. So just here, as always, delete the default cube just to then add the default cube back in, and then we are going into edit mode. Just select this window right here, press G to move it along this axis right here. We can press E, extrude. I'm not trying to do anything too precise. I just want to get a basic view or idea on how I could model this, because I have no clue how I could go about this. So then we would have then scale it down a bit more. This would be the motor mount. Just here. This is... oh, I already hate it. So this would be the motor mount. Then there will be this one, this one, this one. There will be the holes. Cover it up a bit like that. And then we can see so, and the motor will be mounted inside of here, and then then what, good question. Our holes are here, holes are there. We will make this a bit longer so we can mount it to the bottom there. And I think that's it. I don't know if I even had to sketch this, but I will definitely try to draw it one more time. So just for my drawing setup, here video log. Damn, my table. So when you scratch right here. Oh, and it's actually reflecting. It's really reflecting in way much more in the video than it is if you look at it normally. So we just gonna go ahead and try to draw again. First from the front we will have our solid surrounding like that. Then this like there. Put all the parts in. Here and here is the mount, there are the holes. And so then the outer shell would look something like that. And now from the side we have our normal field like that, which would something like this. Then we have the second, which is like this outer layer I want to make. And then on the bottom there is just like this quite overhang, where I will piece together all the files. Then at the top, or from the top, it looks like that. Also 2 pieces on that side, 2 on this right here, and then 3 on this, 1 here, 1 here, 1 here, 1 here. That will be the holes. We will make this one 5 millimeters high. Then this would also be 5 millimeters. That would be, wait, if we had mounted that one on here, so like that. And we see that from here on to the point where we want to mount this hole, we have what length? We have, I would say 15 millimeters, which means we will probably use up, would save 12. So just a raw approximation here would be 12 millimeters, and this would be 5 millimeters again. So then this part here at the bottom would have to be, let me think a bit, it doesn't need to be that much to the side. But it will have to be, we go on like that. I want to make it solid directly from those sides. In there. So like that. So going. The thing is here, I want to keep it quite tight to the motor itself, So at the top I will, how much is it right now? It is 1 millimeter, I think. No, it's actually 3. Okay, then I would say from the center of the first hole we will add 10 millimeters to the top. The top it will be 10 millimeters, like that. So we will have to see how this would go. Yeah, let's just try it out. Go into the CAD model here and see how we are doing. We can just go ahead and model this right off the bat. I'm thinking about just going in here, create scratch. Now I want to bring up this line and bring up this line. This one here. How can I make it vertical? Like that, 90 degrees. And another 90 degrees. Good enough. So then we will have this and this again. So there will be another from here to here. What kind of bullshit am I talking about here? I am just talking some absolute garbage. Let me just see, like that. And I don't even need any more. Wait, let me do here. This, and then the only thing we need to do is create this rectangle from up here to down here, and from here to here. This will be wait, I would have to slide that also from the bottom through it, which is possible, but will be a bit whack. On the sides, I mean, stabilizing them is a big part. So let's not go here all the way in, but we will go from here, something like that, so not all the way to the side, and on the top like that, and then from here So this in the front. 2, 5. So now that means that I can just close this tab and say extrude, hopefully. Of course I can't. And I think I see why. We don't need that plane, that plane, that one, that one, that one. I mean, it can stay. This can stay. No, it can't. This can't. This can't. So now if we go back and say to do that, it recompute failed. What are you talking about? So let me just all of those unnecessary lines. Like this. Delete and delete. That line right there wasn't even a complete line. And this there also unnecessary. Delete. So, and now we can just, okay, I see it, I get your point. Make a triangle from the triangle, a rectangle from there to there. Line 5 and 6 can be removed. Come on, this line. So extrude. I will extrude this 5 millimeters like that, and then on top of here I will go ahead and say create rectangle, go from here and this rectangle to, how do you call it, where is it, there, this nice tool here. Then we will take this rectangle, is there a shortcut for it? Of course there is not. So we are just going blindly here. Yeah, no, that would be a stupid idea to override the stuff that I have done there. Go it up like that, make it the same height as I did previously. Then the eye will be only 2 point something, but it hopefully will be strong enough to hold the forces. Okay. So from that point on right there, we're gonna click close, extrude, and we're gonna extrude that one out by... Now I put the screws away again. Yeah, just open the window. Open. Then here in the screen we will just see how much place I need for that. So this would be 2 millimeters there. Down there. Yeah. Have to see how this works out. I put them in the wrong place. This is one on the bigger scale. Looks like no. The screws right here are actually quite good. Put this out. Let's see it right here. $20 millimeters. And there we go. So what we're gonna do now is painting on the holes there. So again, create a new sketch. This time we want to create some holes. One right here, one right here, one right here, and one right here. Well, not right there, but approximately there. I think you get what I mean. Then we are gonna size them to 3 millimeter, 3 millimeter, 3 millimeter, and 3 millimeter. We will adjust this one to the top part if it would work. We adjust this one again to the top part, as in we have our part which is kind of in here, in here, and here. The center is right there, so there will be one 10 millimeters free room, also divided into the half. So from here to here should be 5 millimeters. So I would want to have that here, and that one 5 millimeters. That one also 5 millimeters, and that one also 5 millimeters. Then we will have this one 5 millimeters from there, 5 millimeters from there, 5 millimeters from there, 5 millimeters from there. So the problem now is they're not really centered, so we will give them like 8, 7, 7, 7, and 7, 7, 7, and 7, 7, and just adjust it. So there we go. If we now close out of that script, right, out of that sketch, we can go ahead and pour it into this point right there. Now we have our holes down to clamp them onto the main rotary part. So now from the center we would need to create a pad which would have the same holes in it, which is possible, and that's why I will just drag it in here. We need to have the top plate, robotic arm, base plates. That's not the base plate, right? No, it is actually the base plate. Yeah, bullshit name actually. So to just take a look at our motor mount. Like that. If we were to look at the parts, this one is positioned at 001, this one also, so they won't show here. Perfect. So if we are just going side of that, then you should already see in the part studio. I think I find it quite confusing because you have like these multiple parts, then you can switch between them, but it won't would automatically if you switch to the task, which would be also a good add-on to have, which there probably is. So round rectangle now, don't need that for now. We will only need to go to the top, and define some kind of rectangle there. So now we would have rectangle width, which should be so just 30 millimeters. So we can do this here as well. Just give it 30 millimeters and now 15 millimeters there to center it. On the line we had it popping out 20 millimeters. Just going above it like that. Then from there we had our circles. They were 3 millimeters in diameter, 3 there, 3 there, and 3 there. So now we have our intersect, which here would be 5 again, 5 here. For them it should be 15. Yeah, looks good. 15 on the line. To the right it is 7. No, 30 through divided by 2 is 15. 15 divided by 2 is 7.5. And of course I put this not on 7.5 because I didn't calculate anything. So just go there, and I want to have this to be 8 millimeters, 7 millimeters. And if I were to remove that again, delete. And I would call that here again. This would be 8, the same as this would be 8. And this right here would also be 8. And this would also be 8. Perfect. So now what we can do, we can remove this unnecessary triangle right there, which serves no purpose. Then we can just simply go ahead and so here this one, this one, so oriented like that, nicely structured. Not nicely, it still looks a bit overwhelming, but it's fine. So going about it in this way is now quite easy, because now you would only have to close this menu and clear out all of these parts, which then should be 6, I think. Yeah, 6 it was. Just apply that, and there you go. So this is where the motor mount is mounted, right? And where it goes over. I will quickly go to the 3D printer and check if my files or how the printer is doing, because I hope it's not. To check on it if it's not failed. So, the 3D printer is quite well. It didn't break. And it should be done in like 3 or 5 minutes. Then I'm gonna check on it. And as soon as it's finished, I will end the stream. Because you definitely notice my English getting worse and worse. And my brain is just not functioning that good. I mean, you can look at my to-do list, which I've done today. I recorded 2 videos, or the audio for them, and worked a lot. And my brain is just fried. So, in a second, I maybe can tell you this, guys, but for the future, I have a few ideas. Maybe you are one of those 2 people that watched my last streams, or were sometimes in the streams, maybe even watched a few of my videos. And I made a few game jams, or I didn't make them, but I contributed a game to those game jams. Like I made one weekend, and I'm not doing any longer game development because I don't like it anymore, and I will shift over to electronics like you see me doing right now, like electronics and engineering. And the idea I had was, why don't I just make some kind of game jam, but in an engineering way? So you get 1 weekend to design a line following robot, and then you have this would be like the guidelines, and then you maybe have a specific theme that you have to follow, or maybe some constraints, like for example you can only use like 1 motor, so you have to somehow engineer an vehicle that only travels with 1 motor, but still follows lines, like you can only use 1 motor to drive the thing, and something like that. And I think that would do for some really interesting projects. So yeah, that was the thing that I might want to do in the next few months. Maybe in like 1 or 2 months I want to set up one of these, if my skills in the CAD, in the CAD softwares get a lot better, so that I can actually be able to design one project on a weekend as well. And maybe it's not even that you have to make a complete project with printed everything and everything working, but I don't think that's even possible in 1 weekend, just printing everything. But yeah, maybe just having some concepts, coming up with concepts, making an interesting presentation about them, and maybe to be entered into the pool of, maybe there will be some prize one day to it, but just so you have like a weekend to design a full project, make some sketches. So you definitely need to do stuff like this right here. You need to do some ideas. Maybe you actually have to do some direct engineering, where you have to draw the pieces and also really constrain, yeah, this is 10 millimeters long and this and the hole and blah blah blah. So you make like technical drawings for it. But for example, the idea was that I at some point make like a jam where you go ahead and have the theme that you build like a Mars colonization bot. So for example, you have to build like one little machine that has to be able to build like houses on Mars with the Martian soil. And you probably won't be able to complete that project in 1 weekend, and probably not in a month. You probably don't have the capacity to shoot a rocket into space and colonize Mars. But maybe building like a prototype, or at least prototyping on the paper, getting some ideas and just getting some stuff together, and then in the end we rate the entries from each other and say, yeah, no, that's the best one and this is really cool, and just giving some feedback. Yeah, no, this looks kind of shit. Why didn't you include the files in there, and why didn't you call it this way? And just so you can put it maybe on, so if you're applying for some jobs in the future, you can say, yeah, I contribute to, or I build some projects in that idea. And then also you can show some files that you actually already did something, or if you're applying to a school, they would probably like that as well. So just building some projects, being able to have that. I mean, with game development or game jams, it was mostly to develop your skills as a game developer, because usually if you develop a fully released game, it takes you like at least 2 or 3 years, or maybe 1 year if you keep the project really small. And the idea of game jams is so you have like one weekend, which is usually like 3 days, where you just have to focus, just completely grind out a full game. That it has to work, it has to have the menu, needs to be playable, so it is fun, it needs to add music and sound effects and everything. So everything that a game usually needs to have in like a 3-year span has to do in like 3 days. And I want to kind of do that into engineering, if you get what I mean. And I always liked the brainstorming phase of it, but then you really have to cut out all the ideas that you're not able to do in this weekend. You still have to do that in the science jam. So if you say like if the goal is like automation, or the theme would be automation, then you can just build a full Tesla factory, design it in 1 weekend probably. So you have to also scope down there a bit, that you're in the time frame are able to design it, and just know your limits and what you can create with it. And this would be like a project that I might just start in the future, like in the next month, where I see where I can host something, or maybe I host my own website where we can just come together and design those projects. But right now my YouTube channel isn't geared towards those people, so my kind of fear right now is that if I would launch this project, nobody would see it or contribute to it, because they that might not be the interest, because they still do like game development or are still from my game development videos. And I gained like, I think 60 subscribers from my new videos now, but it's mostly electronics and not much engineering in there. So I'm not sure how to go about this, is why I should do that if I get like as a 1000 subscriber specials, where I then start to make like once a month or every few months a big game development, big event where we get together on Discord or some kind of platform online, design a project. Maybe we have to form teams of 3 people or something, and then we just all work together and have like this environment where we have to beat the other people but still work together in a group to make cool projects happen. And I think that would be like one thing I would really like to do, and I would definitely apply for if something like this happens. Maybe it already does and I just didn't knew it. But I mean, if you're watching the stream or the relapse, just write it into the comments if you ever heard of something like that. If so, then never mind. Maybe I can still host something like this in the future, but I would contribute this probably in the next streams if there are ones. There are some. But yeah, I think my 3 print should be done now. I've talked like 10 minutes now. So I'm back in a second, hopefully with the finished part. So the print got something, like it is finished, this part right here. So we can just, here, you see it? So we can just now go ahead, put on the screws and just try to assemble it. Just let me see if I'm even pointing towards the stuff here. Oh, there's a lot of noise in the video. Oh, that's a bit less now, a bit better. So you see the part right here? It is a bit bigger now. We have our holes in the back and here places for those nuts to go in. Now I will try if there's enough space for it to be stuck over this stepper motor. My fear is that it does not fit above it because I think I designed something wrong. But with a bit cutting out, so that will definitely have to change for the next versions. It will be easy to slide above it. So it's not going too good. So let's see if it fits now. I cut off like 2 or 3 millimeters of it to see if it fits. Now if we go ahead and slide it over again. We have to see, because we're having to move it over like that. It's a bit tricky, but we can see that it works. We just have to go into our motor mount in the first sketch and put this to like, oh wait, I think there's a slight problem with that. Because now the holes also change. Wait, so 41, and now if I remove this scale, delete those, and if I now go ahead and replace it with this one right here, this one, oh well, oh, this one, and this one. Now if I go here actually on, say it's like 2, then it will be better off. Yeah, hopefully it works like that. Oh, you didn't even see that, sorry. So we have to flip those here around, then those slides on quite easily. Now what I want to try is stuff all sliding those through here. Will hopefully be a bit resistant. Yeah, that's nice, that's good. And those will hopefully fit in there, which they actually do not, at least not that nicely. If I just have something to apply a bit of force, a hammer would be good, but I don't think I have one up here in my room. So if I just, no, that doesn't work. So I can just go ahead and change them as well. Oh, wait a second, what? No, I don't think. I just won't touch it. Then it's probably be fine. So those right here, they are 5.4. Let's make them 0.8, 0.8, 0.8, and here 0.8. Did it now apply those changes, or? F8. I mean, here on paper it says that it changed out of that. But if I take a look at this, I'm not so sure. Yeah, I will take a look at this in a second. But here I want to see if I can somehow get this in. No, not really. At least not without breaking it. Yeah, no. So we have to remember that those need to be a bit sharper, a bit bigger. Yeah, no, fuck this. We're just gonna slide it over. Nothing happened. And then we are just trying to screw some of these in. There. Oh, it's so tricky to get these out here. Accidentally threw one up. So then they will just 2 more of these. I think this other 60mm long. So just put one of those fasteners, I think they're called. No, they're called definitely not fasteners. Washers. Okay. In Germany we call them Mutters. Muttern. Just mothers translated. Oh, my PC just got quiet. I thought for a second it was gonna crash. So we just gonna need the 3mm screw right here. You know, we're not taking the biggest ones there. It will take way too long to get them in and out there. Let's just take these. They're a bit smaller, but still not too small. So okay, you can just screw them in like a normal screw, so they're not that stiff. So we can take the smaller ones right there and just screw them on. I mean, the assembling part is, I think, the most fun thing, especially if they fit together quite well, which this sadly doesn't, but it's still better than nothing, and then assembly still makes fun. So just going ahead and screwing on these. Just now. Just fixating them. I'm actually surprised how well this works without me using any additional these washers, they're called, without using any nuts to tighten them from the other side. So it's just them functioning with the 3D printed stuff, because it's tight enough so they just slide in into their own profile there. Just tightening them a bit more. Okay, if you tighten them too much, I think they get washed out and you won't be able to wash them anymore. What? You won't be able to screw them on or off anymore. But yeah, this looks quite good here. Let me see if I'm even holding it into the camera. This looks quite good here. If those are still sticking in. Sadly, not able to put in those nuts here because they're just too big and the hole's too small. So yeah, then that's it for the stream. I thank you for watching, and I'll probably stream in the next week, probably next Sunday as well, because that's where I have most of my time. But I see if I'm out there, or maybe if I find the time to stream, I will definitely do. Maybe under the week I will as well. But yeah, then thank you for watching, and I see you in the next stream. Have a nice day, boys.